Hi, this is machine learning in Drupal with Tensorflow.js. Make sure you're at the right place. I'm putting this slide deck and the code that I'm going to demo today up on this repository, so you can check that out. A little bit about myself. I've been a Drupal developer for 12 years, working on government agency Drupal website, healthcare Drupal websites, machine learning applications, and software engineering. Currently, I'm a senior Drupal developer at ECS, which is a large company that handles government contracts for doing U.S. government agency websites. Before that, I worked at Tech Systems as a contractor, as a Drupal developer at Florida Blue, working on their Medicare website. So mainly doing custom module development and content. And before that, I worked for 7 months at NLP Logics, which is a company here in Jacksonville, Florida. That's where I'm located at, Jacksonville, Florida, as a senior software developer. And I was doing Python programming for a machine learning enhanced OCR application that they use to process insurance forms. So it would read the insurance forms and put it into a database, and the machine learning would just increase the accuracy because sometimes with OCR, it's difficult to tell a 1 from an L or a 0 from an O. So if you have a little context and some with some machine learning trained models, you can actually increase the accuracy. They had it like above 90%. And then if it reached the confidence interval was low, it would flag for a human being to review it. So it's kind of an interesting application. And that I was doing Python. So what am I going to talk about today? I'll give a short intro to machine learning. I don't want to go too much in depth, so I can get to the demo. What is deep learning? What is Tensorflow.js? These are probably, for some of you, they might be new terms, so I'll go over those and new programs. And then I'll talk about Drupal and machine learning, how they've integrated and use it. And then I'm going to talk about the component module, which is a big game changer in my book, because it allows you to use JavaScript libraries much easier. So I'll talk about that. And then I'll give a demo showing how you can actually do machine learning on a website using Drupal. And then looking to the future, what I see the directions of this going, and then answer any questions at the end. This is Andrew Ning, and I took his machine learning course at Coursera. And he said that just as electricity transformed almost everything 100 years ago, today I actually have a hard time thinking of any industry that I don't think AI will transform in the next several years. So it's just like electricity. It's going to be a new revolution, and it's already having a serious impact on all sorts of technologies, and it's being used through many different businesses, and it's just going to grow and grow and grow. These are some of the companies currently leveraging machine learning application and devices. And probably the biggest one is NVIDIA. If it wasn't for NVIDIA and their development of GPUs, which is graphic processing units, which were made for gamers in the beginning, I don't think machine learning would be where it's at without NVIDIA, because the GPUs allow very fast calculation of very difficult mathematical computations involving matrices. So it's very good at doing that, and that's what was needed for machine learning. They also produce several edge devices like Jets and Nanos. And actually, machine learning can now be done on those devices as well. It's kind of like Raspberry Pi. They just came out with, they teamed up with Microsoft, and they came out with a Megatron Turing natural language generation model. And I'll talk about this a little bit later when we get into deep learning. But it's pretty huge. It has 105 layers. And again, I'll refer back to that when I talk about deep learning. 530 million parameters, and it utilized 4,480 GPUs. Another company using machine learning, of course, is Facebook with face recognition, friend recommender, and they also developed PyTorch, which is an alternate machine learning framework that you can use. It's also within Python. Tesla, of course, self-driving cars with like OpenCV, which is open computer vision. It's a very popular library for processing images. And it's basically machine learning is really driving self-driving cars. Oh, like how I said that. They also announced that they're developing robot just a couple of weeks ago. LinkedIn, they use job search, networking, all these things use machine learning. Others, Amazon, banks use it for detecting credit card fraud. Airports now are using it for facial recognition. Instead of going, showing your ID, you can just put your face to a camera and it will recognize you. So what is machine learning? Machine learning focuses on applications that learn from their experience and improve their decision-making or predictive accuracy over time. And predictive is the key word in this definition, because what machine learning tries to do is develop a model that is very good at predicting the outcome of some sort of calculation, or making a decision to classify whether the picture the model is looking at is a dog or a cat. And the whole point of machine learning is actually to minimize the amount of error in these predictions. There's two types of machine learning. There's what's called supervised learning, and that's where for a set of data, the outcome is known. So you have a set of data, say for a linear regression, you might remember this from your statistic courses, where you have 2 points and you have a whole set of these, and you're trying to predict the line that goes through that minimizes the amount of error, and you're trying to figure out what that equation is. And I'll go over that more because that's one of the examples I'm going to use. Unsupervised learning, this is where the outcome is unknown, but you're interested in how data clusters together into groups. For statistics, principal components analysis and recommendations engines use this. So I'll talk a little bit about this as well. And the one big difference between traditional programming and machine learning is in traditional program, you have some data and then you have some rules that you can apply to that data, and you're going to get an answer out of that. So for example, this example up here, you have your data, say it's the price and the earnings, and you want to calculate the price earnings ratio, which is just price divided by earnings. So you just calculate that out for your answers because you have a set of rules. You're just dividing price by earnings. Well, in machine learning, you have the answers because I said up here in supervised learning, the outcome is known, and you have a set of data, So you want to train your model to actually come up with the rules for actually predicting that. So if it saw some new data, it could actually predict what the answer would be, because you take these rules and you plug it back into this formula and calculate it out, which is called inference. So that is a key difference between machine learning and traditional programming. So what is deep learning? Well, deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and function of the brain, called artificial neural networks. So over here, this is an artificial network, neural network, and you have a set of input layers. Now this input layers, this could be images, this could be text, could be audio information, videos, numbers, but it must be quantifiable. And like images, you can break down an image and make it quantifiable, because you can define a picture by the pixels and by the color values for each pixel. Text might sound kind of weird because you're taking words. You can turn them into numbers using something called embeddings and turning words actually into vectors. So you can actually turn these into numbers, and you can run them through your neural network. The second part is the hidden layers. These are the filters for feature extraction. So these are going to, each one of these has a function called an activation function, which takes the output signal from the previous cell and converts it to some form that can be taken as input to the next cell. So it's going to perform some function on that, and that's going to be passed on. And then you have the last layer, which is the output layer, which is your classification. So say we had an input and we had a picture of dog, cat, cow, or horse. So we go through all these calculations, and then this last layer, the output layer, would classify it. So this first arrow would be the probability that it's a dog. This would be the probability that it'd be a cat, cow, and horse. And then the highest probability is the one you're going to choose for classifying that image. And that's basically how these neural network models learn. And you can put many, many layers in here. Remember, I was talking about Megatron, and they had 105 different layers. So you can take this and extend it out 105 times, and probably each layer is going to have a whole a high number of actual nodes within those layers. So it's going to be that's why you get up into 530 million parameters that it's calculating. That's how many connections it's actually tracking and figure out. And the way a neural network trains is you put your input in, does the calculation, you get your output, and then you're going to see, because remember I said that you know what the outcome is. So it's going to take that outcome and see if it's right, and it's going to calculate some measure of error, and then it's going to adjust these weights inside your input layer, your hidden layers, and it's going to go back through them again and just go through this same process over and over again. And each time the error goes down a little bit more until you finally get a pretty highly accurate prediction. That's the whole thing about machine learning. That's the basic process. So like this is an example of what's called a convolutional neural network. And this is for classifying an image. So you show the model a picture of a car, and it's going to put that input through all these different hidden layers. And these convolutional layers, you can think of it as kind of a filter. So this filter is just a small piece of the image, and then it looks for, by having values in this filter, it could detect a vertical line, or it could detect a horizontal line, a diagonal line, all kinds of different possibilities, and it's going to pass that information. So that's why this layer is feature learning, because you're extracting these features that will, again, best minimize the predictive error. And it goes through all these different layers. You can just kind of chain them together until you finally get this last output layer. And you use an activation function called softmax, which will output a probability for each of these different possibilities that the image might be. And these are all going to add up to 1. So you can be pretty sure the one that's the highest is probably going to be the correct. And again, it goes through and does this a number of times, modifying the values. This is a recommendation engine. So this is where, like say you're at Amazon and it's trying to predict, well, trying to recommend products. It's going to use a number of pieces of information. These are all the inputs that it has. It's going to look at your ratings of other products that you've bought before, your buying behavior, what have you bought before, queries, what have you been searching for, and there's some other attributes that are going to be passed in as well. And then it's also going to look at, inside the recommendation engine, it's going to look at a database with other user preference, and it's going to see how well your user preferences are to someone else's. And if you have similar kind of preferences, then that person is probably going to be a good person to pull a recommendation from you. So it goes through and calculates all these things out, and then outputs a set of recommended products. So you'll get out some sort of products. And hopefully I'll be able to demo recommendation engine. So what is TensorFlow? Well, traditionally, the language most used for machine learning has been Python. And it's a high-level language, very similar to PHP. You have Composer in PHP as your library management, your module management system. And in Python, you have something called pip, which is going to basically do the same thing. It's going to manage your dependencies. In Python, there's a number of different machine learning modules, such as NumPy, which has to deal with representing numbers as matrices. SciPy are just some models. scikit-learn, these are all, again, different models that you can use in machine learning. Pandas is for data frames. So it's kind of like a spreadsheet almost, where you can put your data in, and it makes it very easy to calculate machine learning functions. Matplotlib is used for actually displaying like graphics, graphs, all kinds of things. Keras is a high-level library that kind of sits on top of TensorFlow to make it easier to use TensorFlow. And then PyTorch, again, I said that Facebook introduced their own machine learning framework, and that would be PyTorch. Jupyter Notebooks, Google Colabs, these are interactive in-browser editors that are really popular, because you can put codes into cells, and you can actually run just a few commands at a time to see what your results are. And you can also annotate these with text or images, and makes it really easy to learn through Python. But most of the time, you're going to use some sort of integrated development environment, like Visual Studio Code. PyCharm is one that's specialized for running Python. And one other great thing about Python is you can create virtual environments. So your dependencies, you don't install them system-wide, you just install them for your virtual environment in Atom. And other languages used in machine learning are R, Java, C++, Julia, and now JavaScript. And JavaScript is having a big impact because it's very useful in machine learning and is being used more and more, especially with the development of Tensorflow.js. And here's a brief history of TensorFlow. In 2011, Google Brain developed TensorFlow, and this was for Python, Java, C++. In 2015, TensorFlow is released to the public. In 2017, Google decided, well, can we do the same thing within JavaScript? And instead of using server memory, can we actually use it using the browser memory and computational power to make the calculations local instead of remote? And in 2018 is deeplearn.js was merged with TensorFlow to become Tensorflow.js. So TensorFlow has only been around for about, JS has been around for about 3 years now. And in 2019, they also released TensorFlow Lite, which is a lightweight version of the TensorFlow library that can be run on mobile devices or edge devices such as Raspberry Pis, Jetson Nanos, Google Corel. So it has a lot of different capabilities. So what about Drupal in machine learning? Well, there's 3 really machine learning modules, machine learning libraries, Drupal Compute, and the Recommender API. But they're only for Drupal 7 only. They were never ported to Drupal 8 or Drupal 9. In fact, a couple of years ago, I became like a co-maintainer on these, and I was looking to convert these over to Drupal 8. But when I saw Tensorflow.js, that got me thinking another way, because if JavaScript could be used, that would be much more powerful, because these modules allowed the use of Python or Java code using the Drupal queue. So it just was kind of a clunky way of doing it. And when, like I said, Tensorflow.js, I kind of moved my sights on using that instead of these modules. And of course, there's some proprietary machine learning functionality. Aqua uses it for personalization of websites. And there's also some code to integrate with Azure, some of their machine learning applications for like voice recognition or image recognition, classification, those types of things. But I was looking for something that was open source, and TensorFlow is open source. So that's why I've kind of moved towards that. The other big thing that came out was the component modules. It allows you to use JavaScript within a block. You can do JavaScript configuration and block configuration. And Drupal is set up to work with JavaScript. So this is a key component in me being able to easily use Tensorflow.js within Drupal. Tensorflow.js is a fully developed JavaScript library. It uses WebGL to access GPU for processing, so it's very quick. It's not as fast as like a GPU, but it's faster than just a CPU, actually. So they really kind of fine-tune this, and they use some other techniques to increase the speed. TensorFlow is supported by Google, so they've put a lot of effort into it. And there's a good TensorFlow community, and there's a TensorFlow data set. And so these are a collection of data sets that you can use. So they're all set up to be actually pulled into TensorFlow very easily. And they've also set up Tensorflow Hub, which is a collection of pre-trained models. Because one of the things that you can do in TensorFlow is do something called transfer learning. So you can actually take one of these pre-trained models, say ResNet 50, which I think recognizes about 1,000 different objects for classification. And you could use that model and add some new classification categories or new objects within that library. So you could expand it if it doesn't have the picture, but you would use the power of this pre-trained model, so you didn't have to do all of the training. And also, models developed in Python can be easily converted to Tensorflow.js. Directory structure is for a custom module. Usually just put in the custom directory, and you have a tensorflow.info.yaml, which is for your whole model. Can you still hear me? Okay, just want to check my headphone beeped at me. So within your custom module, you're going to have a TensorFlow, which basically is pulling in the requirement of the component module. And then you're going to have a directory of components. And that's another great thing. You can have multiple different components. So it's kind of like React. You can build a little library of these little components. And each of these components is going to be, you're going to be able to drop them into your block layout just like you would a plugin. So it makes it very easy to do. You're going to have a index.html. It's just a basic template file that you can use. You can specify it to be anything you want, or you don't even have to use one. But I use one just so I can output all the code to it, so you could actually run the examples that I'm going to show you. And then you're going to have your JavaScript file. Just different steps, just like a regular custom module. You do your configuration file, your JavaScript file, which is actually doing your code, and then you create the index. And then you're going to add that component block to the page in the block layout. And I'll show you that. All right, demo time. All right, so this is example. This is kind of like the hello world program in machine learning, is calculating actually uh, the line of best fit, which is linear regression. Some of you might recognize this formula. Y predicted equals mx plus b, where m is your slope and b is your y-intercept. And for this, again, you just have your basic, this is your configuration file. You just define, here I'm pulling in the TensorFlow from CDN, and then I'm also putting in the actual model that I'm going to use. Index, usually this is very simple, but this one, in case I made a more complicated one, that's just this output. So all this is controlled by that HTML file. And then you have your actual linear regret, your Tensorflow.js file, which I will show you. So the basic problem is you have X and Y. This is your input data, and you're predicting Y. So these are known values. So we're going to see if we can train a model to figure this out. And I'm using Drupal behaviors, so I'm sticking the JavaScript code for TensorFlow inside a Drupal behavior just to make sure everything's loaded properly. And here's a function. So when they click on a button I have defined down here, we'll actually run the prediction. Here I'm just providing the data. Usually you can pull in a data set from a file, or you could actually pull in a data file from a remote location. I remember I talked about the TensorFlow database website where you can get actual data to pull in. But here I'm just defining them. Tensor, that's what, basically it's a multi-dimensional array. That's where the name comes from. And here I'm going to define the model. So this is the way that you define your model that you're going to train this data in. So we're going to input this data, and it's going to go through here. And it's going to go through, and we have a very simple model. I just have one hidden layer with one unit, and it's just going to come in and it's going to output. And this loss function, loss is a measure of error. How much error do you have in your calculation? So after it runs through once, it's going to compare the predicted values versus the actual value, and the difference between those, and then squaring that is going to be what's called your mean squared error. The optimizer is something just to optimize your model's ability to learn. It includes like a learning rate and something called momentum, but it's too complicated to really get into. But that's just a stochastic gradient descent is a common one to use. The model summary just shows you a summary of this model. And then this is actually where it's doing the training. And I'm including, so the training is actually an asynchronous function to do the training. And I'm going to do this. Epochs is a number of loops we're going to do. So we're going to do 50 loops. And I'm including a callback, so it will calculate the loss value for that particular epoch, so we can actually see the progress of how it learns. And then down here, I'm also going to, after we train the model, we're actually going to do a prediction. So we're going to predict, okay, if the value is 10, what's the value of y going to be? And so this will output that information. And on this demo, you'll notice I'm doing console log. So I'm just sending everything to the console log. And so there I just trained this model. So again, this shows a summary of the model. There's just one layer. And these are the different epochs. And this is the loss, or the mean squared error. You can see as it goes through the epochs, it's getting smaller and smaller, which is what you want to see. So this amount of error after 10. So if we plug in a value of 10, it's predicting that this model is predicting that's going to be 17.36. Well, let's see how we did. If we calculate it the old-fashioned way, which I did many times in statistics, the estimated value is 18.92. That's a little bit off. The reason it's off is we didn't train it long enough. We only did, again, I said 50 epochs. So maybe we should change this to something more. So we could go in here and change it. But another thing, remember I said that in the component, you can actually put JavaScript configuration into your code. Which I've done. So I'm going to do the same thing here. But in our definition, in our configuration file, we're going to put a form configuration, and the component module explains how to do this. And we're going to call it epochs. It's a text field. It's a number of epochs, default value of 50. So if we go into the block layout, here again, and again, you know, the way I got this in here is after I created the module, you can add blocks. So you can actually go down and just add a component. You can place the block into your content. I just put it there. So this is where it is. And now we can look at the configuration. Okay, I actually set the default value to 250, or no, I changed it. But usually this should, I forgot to reset it. It should have been 50 when it came in here. So we're going to change it to 250. Save your block. And then I'm going to go back to the regression. So we got the same problem. And now in your callback, we can see we have this number of epochs. We're passing it into a value into our asynchronous, the training function. And again, we have our data, the defining the module, and this is where we're actually getting the epochs from the configuration. And this, the component module explains how to do this. So I just pulled it out of the information that was passed into the block. Could look at the source. And I'm also setting up something called Tensorflow JavaScript Viz, which is actually visualization. So usually in Python, you use matplotlib, but here I'm using this visualization. So I'm just entering the information, and I'm going to produce a scatter plot, and then to actually show the scatter plot. And then again, going to do the training and output that as well to this training viz. So we're going to see a graphic representation of the training, which is over here. So I just started the training. So instead of logging the information to the console log, it's just actually logging it to this. And you can see that it's proceeding. I told it to do 250. You can look at the scatter plot of the information, your data. And it's done training. So again, I had it output the number. And our estimated value 18.92. Well, this time it's 18.62, which was pretty right on. Okay, I have to cut it short. So looking to the future, continuing to work on Tensorflow.js module. I need to update the current one I have out there. And I'm also, again, I said you could use different kinds of information going into these models. And I'm looking at doing an AI chatbot for Drupal. Again, just through NLP, natural language processing, and NLU, which is natural language understanding. And also there's natural language generation for generating information. Another thing to do is a recommender for Drupal Commerce and a job recommended. So do I have any questions, answers? Karen asks, can you provide a couple of use cases or examples of unsupervised learning of the text content or reviews on a Drupal site? One again is a big one. I think is could be like a AI chatbot where you could actually answer a question because you can design models to actually generate conversations now. I think that's going to be a real powerful one. And another one would be, like I said, a recommendation engine for Drupal Commerce for recommending products. I actually had an example I did. I took the information from Goodreads and user recommendations, and I think there's 5 million ratings, 53,000 users, and then 10,000 different books. And so I created a model in Python, ran it out. I exported to JavaScript. Actually, the model comes back as a JSON file. You can load that up, and I actually had, so you could enter a user number, user ID, and it would actually show like the top 5 books for that. Is there any other questions? Well, I hope this gave you a little bit of introduction to machine learning. There's a whole lot to learn. I've just been learning for the last 3 years, and I'm really excited about Tensorflow.js. There are also other JavaScript machine learning libraries such as Onyx, which I think you can use PyTorch and fast AI models. You can use that for it. All right. Well, thank you for attending, and I hope you have a good rest of the day. Enjoy the convention. Thank you. And Karen, if you're still there, I mean, hit me up on LinkedIn if you want to discuss, because I'd love to collaborate with some people on different things.